Hello and welcome to the Apalachicola Chattahoochee.
Rachel, are you there?
Yes, Troy. Were you, did anyone hear any of that? I must have accidentally muted my headset.
Yeah, no, I didn't hear it either.
Oh, it was such a good intro. Well, we'll do take two then. Here's an opportunity to do better. Sorry, everybody. So, hello and welcome to the Apalachicola Chattahoochee Flint River Basin Drought Assessment webinar for the month of August. My name is Rachel McGuire, and I'm with the Water Resources Center at Auburn University, located in Auburn, Alabama. If this is your first webinar, just a couple housekeeping items for you. We'll have time for comments, questions, and discussion at the end of the webinar, so please hold your questions till after our last speaker. Also, you can use the question box on the GoToMeeting tool panel to type in any questions you may have during or at the end of the presentation. You can also use the raise your hand tool. There's a hand icon on that same tool panel to do that. Speakers, I just want to remind you that you'll need to unmute yourself prior to speaking, and you can give me a cue for your next slide as needed. Our speakers today will be David Zierden with the Florida State University Florida Climate Center, where he is the Florida State climatologist. He'll be speaking about our current drought status as well as our seasonal forecasts and outlooks. We also have Tom Littlepage, branch chief of the Alabama Office of Water Resources. He'll speak with us on our state of Alabama input. We also have Paul Ankhorn, a hydrologist with the USGS South Atlantic Water Science Center. He'll speak about our stream flow and groundwater conditions. We also have Troy Ephraim of the U.S. Army Corps of Engineers Mobile District to speak with us about our ACF reservoir conditions. And we have Jeff Dober of the Southeast River Forecast Center, who will be speaking with us about some of our stream flow forecasts for the ACF. And lastly, we'll have a special presentation from Cameron Handyside of the University of Alabama in Huntsville, Alabama Office of State Climatologists. He'll be speaking with us about the Lawn and Garden Moisture Index, which was developed at UAH. And it's something that we regularly see from David in particular during our webinars. So it will likely be a familiar tool to many of you, but we'll have some more background information thanks to Cameron. So special thank you to him for being here today for that special presentation. With that, I'll turn it over to David, our first speaker, for our current drought status and our seasonal forecasts and outlooks. Are you ready, David? David, can you hear me?
Yeah, I was not able to unmute on my end, so I guess you did it. So anyway,
okay.
You hear me now?
Yes, good to go.
Okay, great. We'll begin this month's webinar as we kind of gotten in the habit of doing by looking at what's in the news. And last month we had Hurricane Isaias for the national media to struggle over. And since then, we've had the Iowa derecho, and now we've got the Fujiwara going on. Very simply, the Fujiwara effect, it describes how two tropical cyclones in close proximity can interact and alter each other's tracks. But with this current situation, that was really never in play. As we see the forecast from several days ago for Tropical Storm Marco and now Hurricane Laura, they were forecast to cross paths, but with several days in between. Marco was forecast to make landfall Monday morning, where Laura was not forecast until Wednesday or now even Thursday. So they really weren't going to be close enough that we were never really going to see this Fujiwara effect in the Gulf. But as the fellow on the bottom left shows, there was a lot of confusion. Here he has icons showing two fully developed hurricanes, not really close to their forecast track in the Gulf, as he tries to explain this this effect. And we had heard a lot about how this is unprecedented. Yes, there have never been two hurricane strength storms in the Gulf simultaneously. Only twice before had there been two named storms at the same time in the Gulf, in 1933 and 1959. And we'll have to do a post-mortem on this and see if actually Marco was still at tropical storm strength while Laura was entering the Gulf, see if that actually happened this time. But we're not real sure on that right now. So that's what we were promised. But on the next slide, we'll take a look at this morning and what's actually happened. Marco did make landfall along the Louisiana coast as a tropical storm. So that makes it the sixth named storm to make landfall in the continental US so far this year, tying with 1886 for the most named storms to make landfall this early in the season. We are still on pace for a record-setting year for named storms, as Marco and Laura were both the earliest M and L named storms in history. We are above, while not a record-setting pace, we're above average for number of days with named storms and also for ACE, or accumulated cyclone energy. We still have not had a major hurricane yet. It's looking like Hurricane Laura will make landfall at least as a hurricane strength, and even forecasted as a major hurricane. And that'll make 3 hurricane landfalls prior to August 27th. And that has only happened twice before in history, in 1886 and in 1916. And all of this information is courtesy of Phil Klotzbach at Colorado State University. So that's what we're looking at this morning. We'll go to the next slide and see what it really means for the ACF Basin. And it doesn't look like we'll have any direct impacts from either of these storms other than rainfall. And over on the left shows yesterday's estimated rainfall from the radar and multi-tensor precipitation estimates. And you see very heavy rainfall along the western Florida panhandle and up into southeast Alabama and across most of south and central Georgia. So the Georgia rainfall might not have been a direct impact from Marco, but certainly it was a player in the heavy rain they received yesterday. And over on the right is the forecast rainfall from Hurricane Laura as it makes landfall, with possible heavier amounts over North Alabama and Northwest Georgia, and possibly the upper ACF basin. Not a lot of impact from Laura in the middle and lower ACF. So that's what's going on in the tropics. Still a record-setting year for hurricane activity. So on the next slide, we'll take a look at where we are as far as hurricane climatology. And the top left shows all historic hurricane or tropical storm formations in the first third of the month of September. And what we see is the main development region from the coast of Africa to the Lesser Antilles really becomes active in September. Also, formations in the Gulf of Mexico are very common at this time of year, and off the east coast of Florida. And we've all seen this bottom graphic, which just shows hurricane activity, historic hurricane activity throughout the tropical season. And as here we are, August 20th really marks the beginning of the most active phase of the tropical season. So we're right in the heart of it. We've got tropical activity right now, and expect more in the next coming weeks. So on the next slide, we'll shift gears and start looking at the drought situation. And as we discussed last month, there are some pockets of abnormally dry and even a small amount of moderate drought in southeast Alabama. But these are mostly indicative of short-term deficits and the scattered nature of summertime convection over the tri-states region and the ACF Basin. Mostly short-term. This map is bound to change a good bit come when it's released on Thursday, as we saw that heavy rainfall from the remnants of Tropical Storm Marco. We also see some moderate drought and abnormally dry conditions along the west coast of Florida, but those look to improve also this coming week. So on the next slide, we'll take a look at the Lawn and Garden Moisture Index, and I'm glad Cameron Handyside is here to explain it more fully, but it really is a good indicator of short-term drought and crop health during the summer growing season here in the Southeast. And the current Lawn and Garden Moisture Index shows a good bit of improvement from last month. Most of the area and all of the ACF is in pretty good shape, mostly moister than it is dry. We do see some dryness settling in northwest Alabama, though. So on the next slide, we'll take a look at recent rainfall, and here's 30-day precipitation totals, again, radar estimates. It shows above normal rainfall for most of the state of Florida, including the peninsula and the coastal panhandle. Again, you see more scattered, but mostly normal to above normal across the middle ACF, the state of Georgia, and southern Alabama. On the next slide, we'll look a little further back, and now this is not rainfall totals, but departures from normal over the last 90 days. And we see how the last month or several weeks have really caught things up across the entire ACF basin. It's near normal, some spots of above normal, one little pocket still of showing deficits in southeast Alabama, but much above normal for southwest Alabama and much of the state of Florida. So on the next slide, we'll start looking ahead, and this is the 7-day quantitative precipitation forecast from the National Weather Service. Again, you can clearly see the anticipated track of Hurricane Laura, and it will bring very heavy rainfall to Louisiana, Arkansas, Tennessee, and possibly even portions of the upper ACF Basin, northern Alabama, northern Georgia. However, the middle and lower ACF Basin will really miss the impacts from this hurricane, and we should have climatological rain chances, afternoon thunder showers, no heavy rainfall anticipated at this time. So on the next slide, we'll take a look further ahead at the state of the Pacific Ocean. And I have to backtrack. Last month's webinar, I was kind of downplaying the chances of a continued development of La Nina conditions, but I have to backtrack on that. They seem to still be in place and even growing. The top graphic shows the current sea surface temperature anomalies, where we're starting to see a very well-defined cold tongue and more of a getting closer to a mature La Nina event in the Pacific Ocean. And over the bottom graph is our familiar Nino 3.4 index, which shows that we have been below that -0.5 degrees Celsius threshold since around mid-July or so. So we've had several weeks, 5 or 6 weeks in a row of sea surface temperatures in that region being below or exceeding that La Nina threshold. So on the next slide, we'll take a look at what's happening beneath the surface. And over on the right, it shows week by week the evolution of subsurface ocean temperature anomalies across the equator. It's a cross section. It shows temperature anomalies at depth. And 3 weeks ago, it looked like most of the anomalies at depth were confined to the far eastern Pacific and were going away. But as we see at the bottom graphic and over on the left, we've got another fairly strong upwelling Kelvin wave, creating negative anomalies below the surface across much of the central and eastern Pacific. So this is more reinforcement for those cold sea surface temperatures and the continuation of La Nina conditions. So on the next slide, we'll take a look at the official forecast. And now the probability of La Nina conditions setting in by this fall has increased from around 55% last month to now it's over 60% for that October, November, December timeframe. And over on the right shows, again, the different models and how they are predicting sea surface temperatures in that Nino 3.4 region. And they're definitely coming together more closely, and the ensemble average is certainly into La Nina conditions into the fall and even winter of this year. So both the models and the observations are supporting continuing and possibly strengthening La Nina conditions as we go into the fall of the year. So with that in mind, we'll take a look at our the seasonal outlook for, I'm sorry, this is actually for September through November, the temperature and precipitation outlook from NOAA's Climate Prediction Center. And over on the left, a familiar pattern, most of the United States with increased chances of above normal temperatures, especially in the Southwest United States where they've been plagued by a real heat wave and stubborn high pressure aloft. Over on the right shows the precipitation forecast with increased chances of above normal precipitation for Florida and the Southeast, portions of the ACF Basin. And this is based mostly on the continued forecast for an active tropical season in the Atlantic. And speaking of which, on the next slide, I'll just quickly review the latest update from NOAA for their seasonal hurricane forecast, where now we have a very strong likelihood of an above average season, 85% chance of above normal activity, only a 5% chance of below normal activity. And with the recent storms and the continuing record pace, that seems like it's really off the table at this point to have a below average year when it all ends up. And over on the right, you can see their forecast for the number of named storms, hurricanes, and major hurricanes. And on the next slide, we'll wrap up with the seasonal drought outlook. Not much to say because there's not much real drought in the eastern United States, certainly not in the southeast. Remember that yellow coloring on the drought monitor or abnormally dry does not mean drought. It just means areas to watch out for. So we have the small spot in southeast Alabama and also around the Tampa area where we do have moderate drought, but being still in the summer rainy season, those areas are forecast to improve. And with that, we'll go ahead and wrap up. And oh my goodness, I apologize. These are my summary points from last month. So we'll just have to reiterate that the active tropical season, the near record tropical season continues in the Atlantic. The remnants of Marco brought some drought relief and will show up in Thursday's drought monitor map, I assume. We do have continued and even strengthening La Nina conditions in the in the Pacific Ocean. So once this tropical season kind of runs through its course, we can maybe anticipate the onset of dryness as we get into the fall and winter seasons. Here across the Southeast, we've been above normal rainfall for the last 30 days, certainly in the lower and middle ACF Basin. And that looks to continue with the continuing tropical season.
Thank you, David. Now I'd like to turn it over to Tom Littlepage for the state of Alabama input. Are you ready,
Y'all
Tom?
hear me?
Yes.
Can you hear me? Okay. Well, this will be short and sweet. Go ahead, go to the first slide. Oh, I guess I need to turn off the transition. Sorry about that. So essentially, this is the map. I think David showed the blow up of the 3-state area as it was last week. The current draft shows some significant reductions in both the amount of D0 and the D1 area in Henry County. Next slide. As a result of our last MIG meeting at the end of July, we modified our drought declaration basically to reflect the dryness in southeast Alabama. Even though there were isolated spots of the D0 in other areas of the state, this was the area that had the most significant drought conditions. Next slide. And we continue to, this has not changed since the last meeting or presentation, but this continues to be a place where, as we hear about impacts associated with drought, we will post them out there for people to be able to see. Next slide. And so, as David so eloquently alluded to, we're going to see some rain in many areas of the state as a result of now Hurricane Laura. I did this before they had upgraded it. But we don't know exactly where that is, but I think we're going to continue to see this pattern of isolated rainfall. And for us this year, it has been fortunate in the sense that we're not having any significant drought-related impacts in ag so far this year, and we'll continue to monitor that to see how it continues as we go through August, September, and even into October. And that's it. I'll be happy to answer any questions.
Thanks,
oh, yeah,
Tom.
I'm sorry. Sorry, this is our next meeting, which is next week of our drought group. So if y'all are interested in participating, please let us know. This will be a virtual meeting, and we'll be glad to send you a link. Thanks.
Thank you, Tom, for that update. And now I'd like to turn it over to Paul Incorn with our stream flows and groundwater conditions. Are you ready, Paul?
I am, Rachel. Good afternoon.
Sound good?
All right, so we'll begin with our usual overview of the Southeast. These are real-time gauges from our previous webinar. Not a lot of change. Well, the major change you'll see is the flow conditions in North and South Carolina, particularly Western North Carolina. 4 weeks ago, we were looking at pretty much normal flow across the region there, and now, as of this morning, a lot of those gauges are reporting high and much above normal, which is indicated by the black and the blue data points. Another thing or point of interest there, last webinar, we were looking at much below normal conditions in the Middle Flint River Basin. And as of today, a lot of those gauges now are reporting much above or above normal conditions. So we're sort of lagging in the Flint River. A lot of the gauges were still showing below normal flow for most of the summer, and looks like we've caught up, and that's good news for the Flint. Rest of the basin is ranging from much below normal, which are just points on the Chattahoochee there that are likely regulation affected, but as a whole, the most of the ACF basin is ranging in the normal flow conditions. So that's good news and plenty of flow. So we'll look at the next slide, and this is the below normal 7-day average stream flow. So this is indication of hydrologic drought. We've seen some improvement from our previous webinar in Southeast Alabama and Southwest Georgia. We had some moderate hydrologic drought 4 weeks ago. Things are improving. There's still ranking on the scale there, but they're just showing in as below normal right now. So hopefully we'll see continuing improvement in that tri-state area. All right, next slide. We'll begin by looking at the 7-day average stream flows. So that's the black line there is the historic, or the previous 28 days daily flow, and that is compared to the historic flow for that day of the year. So these two stations here are inflows into Lake Lanier, and from our previous webinar, we've seen a slight reduction, but in the past week or so, we've seen a slight increase at Cornelia and a little more flow at the Chestatee River. But both stations are showing normal conditions for the 28-day average flow. We'll go next slide. These are our stations moving downstream below Lake Lanier. So since our last webinar, Chattahoochee River at Atlanta actually dipped into the below normal 28-day average flow for about a week or so. But recent rains have upticked it, and we're currently heading towards the 50th percentile. And Chattahoochee at Whitesburg, same increase in 28-day average flow, but they're both still in the normal flow conditions, which is what we would expect for this time of year. Next slide, move further downstream to West Point and Columbus, where West Point is right around the 50th percentile, so ranking at normal, and then Columbus is just moved from 24 to about 26th percentile there. So that's showing normal 28-day average flow for both stations. All right, next slide, we'll switch over to Flint River Griffin in Carsonville, and both stations are showing normal 28-day average flow. Next slide, further downstream to Albany and Bainbridge. Again, same conditions there, normal flow. And then the final slide here for flow conditions, that's Apalachicola River Chattahoochee, and that's hovering right at the demarcation between below normal and normal, but a slight trend towards the normal direction. So, and yep, here we are with, these are real-time groundwater conditions. So the current brief is showing conditions to mostly be in the normal elevation range for the wells located in the ACF Basin. Two stations are showing, well, one station is much above normal, and then conversely, right around Columbus, we have an elevation of much below normal. But as a whole, groundwater conditions look good and ranking in the normal zone. So we'll look at the slide at Miller County, and the elevation there is pretty much flattened out for the past month. We're seeing a slight uptick in elevation and currently ranked in a normal condition. Next slide, Doherty County. So we see a little more fluctuation with this well, likely due to pumping, but we are seeing an upward trend that's moving towards above normal. And next slide, we'll just wrap up with real-time stream flow for the basin. It's currently in the high to low range. Portions of the ACF Basin currently ranked as below normal for the 28-day average flow, and Chattahoochee, looks like I'm sorry, I got sidetracked there. The 28-day average flow for the Flint River is currently in the normal range, and then real-time groundwater conditions for the ACF range from much above normal to much below normal. But as I showed, majority of the stations are currently ranking normal. All right, Rachel, that's it. Thanks.
Thank you, Paul. Now I'd like to invite Troy Freedman to speak with us about our ACF reservoir conditions. Are you ready, Troy?
Hey, Rachel, can you hear me?
Yes, I can.
Okay, perfect. All right, we'll start with the next slide. We got Lake Lanier, and the current elevation there is 1071.3. And over the next 5 weeks, we're anticipating to stay right near the top of conservation and follow the guide curve. On the next slide, we got West Point, and the current elevation there is 635.48. And we've been operating about a half a foot above guide curve since the drawdown at Walltrap, George, to be able to support the minimum downstream flow requirement. And next, we got Walltrap, George, and the current elevation today is 188.22, and that is because we got a little bit of rain there from the tropical storm band, and we're anticipating to be able to meet our 186 elevation by September 15th. We will just have to be a little bit more aggressive with our releases. Next is Jim Woodruff, and the pool elevation is 77.13, and we're expected to stay there. And same with the flows on the Apalachicola River. We'll just have to be sending a little bit more with the releases that we're making out of Walltrap storage. And here's the ACF Basin Composite storage. We're currently in Zone 1, and even with the drawdown at Walltrap storage, we will stay in Zone 1 over the next 5 weeks. So as Paul just mentioned a few minutes ago, the inflows into the projects are normal right now, and Lake Lanier and West Point are operating just slightly above guide curve. Walltrap storage is still in Zone 1, and the drawdown officially began on August 1st for the upstream dam repairs to an elevation of 186. And we expect our projects to remain near or approach guide curve over the next 5 weeks, and that's the same for the ACF conservation storage to stay in Zone 1.
All right, thank you very much, Troy. Now I'd like to invite Jeff Dover to speak about our ACF stream flow forecast. Are you ready, Jeff?
I am. Can you hear me, Rachel?
I can.
Okay, super. Okay, well, I think David and Paul and Troy set the stage perfect for our September forecast. As David pointed out, the last 30 days have been precip across the basin have been near normal, and it looks like for the most part the outlooks look like in the normal range. And as Paul pointed out, most of the stream flows are in the normal range right now, and we'll continue to see that trend, I think, into September. And as Troy pointed out, inflows into all the projects are normal, especially Lake Lanier. So with all that being said, I think we're going with a near normal September forecast, near normal for the entire ACF for September 2020. And as far as the 3-month outlook, again, based on all these current observed trends and the forecast, our forecast now going through the month of November calls for mostly near normal conditions. As you can see, the pie charts there showing, if the pie chart showing there, more likely, the most likely case is going to be near normal to above normal. The least likely chance at many of our locations is going to be below normal. So, but for now, we're going to go with near normal across all the ACF for September, as well as September, October, and November, taking us into the cold season. So that's pretty much the forecast. The 1 month and 3 month stream flow forecast near normal.
Thank you, Jeff. And our last speaker today will be Cameron Handyside with a special presentation about the Lawn and Garden Moisture Index. Are you ready, Cameron?
There we go. Can you hear me, Rachel?
Yes, I can.
Okay, great. I hope I'm coming in clear. I'm doing this over my cell phone.
You are much clearer.
Thank you. Okay, great. So, well, everybody, thank you for this opportunity to talk about one of the products that's been around from UAH for quite a while. So the Lawn and Garden Index, we describe this as a simple drought tool for the Southeast. So next. So I have to tell you right off the bat that the Lawn and Garden Index was developed long before I started working with Dr. Christie at the Earth System Science Center in the State Climate Office here in Alabama. And so I was sort of having to go back and get the history from Dr. Christie and some of the other developers that are still with us at the office there. But basically, it boiled down to Dr. Christie, as a state climatologist, came to a group of developers and asked them for an index. And he basically had some basic criteria. And so I kind of want to go through that real quickly to give you an evolution of the product. And so he said, first off, that this index had to incorporate water stress of shallow rooted vegetation. And so that boils down to, this is in the early days when we were still using the drought monitor for agricultural drought. And we understand the limitations there, and that's certainly not a ding against the drought monitor. It cannot be all things to all people. And so what Dr. Christie was looking for in that was something that was a little more attuned to basically vegetative drought stress. The next criteria he gave the team was he needed something that reflected the quickness or speed of the hydrologic cycle. And this has to do with, partially the fact that in the Southeast, when I tell people that down here we get 50 or 60 inches of rain a year, and yet we can still experience drought, people out west are just dumbfounded at that. But, you have to point out that we have an ecology that actually uses that 50 or 60 inches of rain. So we have an environment that's built around those high precipitation values, but that also means we have vegetation that it has an extremely high ET rate. And so he wanted something that would respond to that dense vegetation. One of the other key things here is our poor water holding soils. So everybody in the southern part of the state understands that sandy soil basically allows water to pass right through it. And up here with our heavy clays, the joke is you can go from flood to drought in about 7 days in North Alabama. And so he wanted something that tried to capture all of that information. He also made a joke there that said if we had good water holding soils in places like Alabama, we'd probably be a continuous lake. So, it's a recognition of basically what we're dealing with in our environment. The other thing he needed, and one of the criteria, was good spatial resolution. At that time, much of the information was being dealt with at a county level. And everybody here knows that during the summer months with those convective storms that inside one county you can experience 2 or 3 different levels of drought. We literally have farmers talking about a farmer on one side of a road experiencing extreme drought while the other farmer on the other side of the road was doing fine. And finally, what we were looking for was something that's simple and useful. And sometimes I catch myself when I'm talking to the general public about drought, and you start talking about things like the NDVI or crop model stress indexes, you start to see some people maybe losing some of the general public. And so what we were hoping for was something that would be very simple and very useful. All right, next. And so I wanted to talk quickly before I even got started there. The development team that worked on this was actually obviously Dr. Christie, the state climatologist. He's the head of our Earth System Science Center. One of his key developers who has unfortunately passed long before I got to meet him was Benji Norris. And apparently Benji was sort of Dr. Christie's go-to guy for so many different projects in our office. Philip Jones, who was a graduate student at the time, who I believe works up in Asheville, and I didn't confirm this, but I believe Philip now works at the NCDC. So he's gone on to bigger and better things. And then Don Moss and Kevin Doty, who are both developers and meteorologists that still work with me today. So both of them are colleagues of mine. And I wanted to make sure that the only credit I deserve is actually putting together the presentation and being a user of the Lawn and Garden Index. So this was the team that put all this together. So next. So the very first component of the Lawn and Garden Index is actually precipitation. And for the precipitation input that we use the NCEP Stage 4 precip. And so I think Dr. Zierden showed a map of this same product, the last 30 and 60-day cumulative precipitation. And just for everybody's, information, the NCDC is basically a radar and gauge-derived precipitation analysis of the Southeast. And, ours is managed by NOAA, and the Southeast River Forecast Center uses this extensively, and we do as well. So we use this, extensively in a lot of our modeling and other applications. And one of the key things that came, that the reason for using this was the resolution, right? You're at about 4 kilometer resolution there, 4 to 5 kilometer resolution for this precip data, which gets us down to that sub-county level that Dr. Christie was looking for. So a much finer resolution than they had previously. So next. So here's where the product itself starts to take off. So what the team did was they developed what they called an effective weighted precipitation. And what this does is this basically takes the cumulative precipitation over the last 21 days and it weights it. And it gives more weight to the most current 7 days of precipitation in this index. So as you can see here, the farther from the current day you get going out to that 21 days, the less of an impact we think that earlier precipitation has on the index or on the plant. So we're looking at vegetative health. So for example, if you're getting 1 inch a week over the last 3 weeks, that's a cumulative 3 inches of precipitation. However, that inch of rain that we received 3 weeks ago would have less of an impact on the current condition of a plant today. And so what they tried to do was to create what they call this effective weighted precipitation. Now, once we get to this point here, when we talk about effective precipitation, this starts to talk more about an index and less about the actual conditions on the ground. So bear with me. I hope this will make sense as we kind of go through it. All right. So next. So then what we do is we take that effective precipitation and basically we compare that against what we would consider a healthy standard effective precipitation. And this is basically, we're looking at the seasonal estimate for plant water demand. And this is very general. So, at the end of this, we'll talk about some of the caveats and assumptions we have to make. But a very crude assumption here is assuming that we need about 1 inch of rain every week for healthy lawn and gardens or healthy vegetation growth in the summertime. And that sort of goes back to, sort of rules of thumb that, if you go to your master gardener classes and even talking to farmers, about 1 inch of rain during the growing season is about what you're looking for. But during other parts of the year, other seasons, you don't need that high level of precipitation to maintain the same vegetative growth, even though, things are green throughout the winter months in a lot of places in the southeast. And so you can see that tapers off. And so what we tried to do here is to create a curve that reflects the seasonal variability of plant water demand. And so if you're looking at it right here in January, we need an effective precipitation, not actual precipitation, but an effective precipitation of about 1/2 inch. That goes all the way up to about an effective precipitation of about 2 inches in the warmer growing season. All right, next. And so the index is really just a departure from that normal, just like we looked at precipitation departure maps. And so all we simply do is we take the current effective precipitation, we multiply it by that weighted factor, and then we subtract or take the difference between that and the standard that we hope to get and that we hope to see throughout that growing season. And so, again, what we're looking for here is just a general average. In the summer months, we're looking for about that 1 inch a week in precipitation. And in the winter months, that drops off to about 1/4 inch, somewhere around 1/4 inch. Next. So to try to give you an example of this, just to try to bring it into the real world. So in January, 1 inch of effective precipitation would actually be about, 1/2 inch above what the actual standard precipitation would be looking for. So in January, 1 inch of effective precipitation would put you well into the green or well above the normal for the index. However, in September, that same 1 inch of effective precipitation would give you a deficit simply because of the current water demand that vegetation would be exerting. Next. So I tried going through and looking for some examples that would try to illustrate this across the Southeast. And so these are a couple of maps. And this doesn't look like our standard lawn and garden index that you see on the website, but these are some of the products we put together along with a variety of other products. But what you see here is this is January 2018. And what you can look at on the left, you see the lawn and garden index in there where everything is about normal to green. So you see a very wide pattern of basically good health. The vegetation in January, or at least the demand vegetation would be putting on water resource, would be about normal to green. And if you look at the 7-day cumulative precipitation on the right, you see that, there's a band of about 1 inch running through the middle of Alabama and up through Georgia. But you see in most of the areas there, we're only at about a ½ inch. So that ½ inch of precipitation over the last 7 days was all the vegetation really needed. On the other hand, if you go next to the next slide, you'll see that this is the Lawn and Garden Index same year in September, 2018. And you'll see that there's some large swaths of red and orange in Georgia, especially over in North Georgia, where you see a deficit. So you see an actual vegetative, water demand deficit. So there's not enough water present for what we think that the vegetation would be requiring. And so if you look at the 7-day cumulative precipitation, you'll see those same green and blue bands in precipitation. So they were getting that same, ½ inch to 1 inch of precipitation over the last 7 days, but that's not enough because of the different seasonal demand. So next. And so, I hope that's a little clearer for everybody. I don't want to try to confuse anybody, but you can actually, we have on our website where we actually publish the Lawn and Garden Index daily. You can actually see sort of an explanation of the information as well. And so I wanted to make sure everybody knew that the website was out there, and that's still a current product of ours. All right, so next. Okay, so, I wanted to point out very clearly that, this is one of our older products, and that, UAH has been part of teams that have worked with some of the more complicated products. We run crop models, we run, a variety of remote sense products across the Southeast, trying to come up with better ways of defining drought. And so, it's kind of ironic that some of the early products, the simple product, actually still does a pretty decent job, when we compare it to some of our more complicated crop drought models. And, my conclusion here is, it's limited, and let me talk about some of the assumptions and caveats we have to make. The Lawn and Garden Index does not differentiate between different soil types. It simply uses sort of a empirically derived water demand based on, gross or large-scale spatial ET. Nor does it really, reflect the variability of plant species. So, we're not separating out things like pasture and grass versus, high-demand crops like corn or even forest products. However, it does provide a simple, clear snapshot of plant stress, and and it captures that recent precipitative history, and it starts to show that lead and lag time that so often is missing from some of our more complicated drought products. And we've done some comparisons, when you're looking at large scale maps, as droughts start to develop, the simple Lawn and Garden Index really does a pretty good job of capturing some of those early signs of drought, just like some of our more complicated products. All right, and I think that's it. If there are any questions, I'll be glad to try to answer them. And if not, then I'll certainly give you contact information in our office that can help you with more detailed information on that.
Thank you so much, Cameron. That was really interesting. And forgive me if I missed this, but did you know the approximate year that this product was initially released?
I was trying to dig back through the archives to go back to see when they actually started developing it, and I couldn't find the actual year. And I shot off an email, but I didn't get a response before that. So I've been working at the Air System Science Center for, over 13 years, and so it was a lot earlier than that. And so we have probably at least 15 years there. Maybe Dr. Zierden might remember when it first came out, because it was part of the development for the Southeast Climate Consortium, was sort of one of the early adopters of the index.
Okay. Very cool. Well, I really enjoyed that. It's something that I see quite often. And it's nice to know the backstory. And I didn't realize that there were 21 days of precipitation weighted that way. I thought it was more based on just the last 7 days. So very interesting. So now I want to open it up to any comments or questions for any of our speakers. You can type in your question, or you can raise your hand, or if you're one of the speakers, you can unmute yourself if you have one for another speaker.
I have a question.
Yes.
From the lawn garden index, I don't remember seeing what is a good lawn garden index. So from 0 to 2, I'm assuming 2 is the best.
Yeah, that's correct. So it ranges from -2 to 2, and so neutral would be 0. Anything negative would obviously be bad, and it corresponds to that. The old rule of thumb is about an inch of precipitation a week. And so when you see if you're at +2, you're getting well above an inch a week. So.
Okay, thank you.
And then there was also a comment from, oh, I'm sorry, go ahead.
I was just going to say, and one of the things when we have to make sure our index sometimes uses inches in the index, but it's truly just the -2 to 2 is a it's a unitless index.
David commented that he was thinking it was 1999 that the lawn and garden had to come out, or around that time, and that it was initially just Alabama and then expanded to more of the Southeast after that. Any other questions from the audience?
Hi, I have a question for Cameron. Thank you so much. The coverage right now is for the Southeast, and it makes sense for all the reasons that you mentioned, the soils, the hydrological cycle, etc. Is this useful, this index, for any other parts of the U.S.? Has it been tested, or are there similar indexes used in other regions kind of following this model?
So I actually was doing a quick data search to see if there were products like this in other parts of the country, and I didn't see anything right off the bat. And I think we'd have to have a discussion about expanding it beyond the Southeast, because this captures our high ET levels in the Southeast. So if you get out to the desert west, I don't know how the model would have to be modified to work, and some of those other conditions. So, I was just out west, and basically if it's green, it's irrigated. So, it's a little different situation out there.
Great, thanks. And I agree, this is a really useful tool for early warning of drought. So thanks.
Well, if we don't have any other questions, I'm not seeing any. I want to thank one last time all of our speakers today: David Zierden from Florida State University, Tom Littlepage from the Alabama Office of Water Resources, Paul Inkhorn from the USGS South Atlantic Water Science Center, Troy Ephraim from the Mobile District Army Corps of Engineers, Jeff Dober from the Southeast River Forecast Center, and Cameron Handyside from the Alabama State Office of Climatologists. Thank you very much for your presentations today. And a reminder to everybody, our next webinar will be Tuesday, September 22nd, at the same time, 1 p.m. Eastern, 12 p.m. Central. There will be a video recording of this webinar posted to YouTube within 48 hours, and I'll also be sending out a synopsis email as usual. My contact information is displayed. If you have any questions or issues that you had with the webinar joining today, anything like that, please let me know. And thank you everyone for being here with us today.
Thank you, Rachel.